Good afternoon. My name is Nyasha Yuda Ganda, and I'm a student at the University of South Africa. I'm here to present my road designing project under TPG3700 for this year 2022. Introduction. The design of a road pavement is very complex. Before design can commence, the engineer needs to know the climate of the region where the pavement is to be constructed, which plays a role in selection of pavement material. Higher temperatures result in the need for increased frequency of surfacing due to more rapid oxidation of the bitumen. The soil on which the pavement is going to be constructed should be tested to determine whether there is need to strengthen the subgrade. The design of the subgrade layer depends on the CBR value and also the load of that is expected on the pavement. Pavement designs aim is to protect the subgrade from traffic loads by providing pavement layers which will achieve a chosen level of service. The load expected on the pavement also plays a big role in selection of material type and thickness of the layers of the road. Heavy trucks and buses are continuously loading pavement. These loads are transmitted through the pavement to the subgrade. The project aim. So the aim of this project was as intended to give the student a practical insight into some of the aspects of undertaking design of a major road. We are required to upgrade a gravel road or a road that has reached its end life to a standard surface 4-lane divided road. The designer is required to generate the final alignment by utilizing a commercially available geometric design software and prepare a detailed structural design of the pavement of various road sections. The project overview. Background. The Faculty of Civil Engineering at the University of South Africa has been requested to provide a proposal with the engineering knowledge and techniques to find and optimize the road alignment. That is the horizontal, vertical, and transverse, and pavement layers of the major road. The project brief was issued via the website, and the setting out data for the chosen centerline of the road was collected from a consultant surveyor. The aim of the project is to redesign a road code N2 using Civil Designer program. This road is 4.1 kilometer long and it has reached its end life. It is situated close to Pietermaritzburg Bay and Pisan River. The road comprises of potholes and rolling terrain with almost steep gradient in some areas. We have to reconstruct the road from subgrade to the surface as well as considering the traffic and the category of the road. The climate of the area. The area is a tropical climate with majority summer rains. The average annual temperature is 21.8 degrees Celsius with an annual rainfall of 901 millimeters. The driest time of the year is June, with rain of about 38 millimeters, and the highest precipitation is recorded in March, with a peak of about 111 millimeters. July is recorded as the coldest month, with an average temperature of 18 degrees. TRH4 suggests that this area falls under wet climate region. So as we were searching about the area, this is the layout of the area. So the below layout we acquired from the Google Earth in March 2022, and any building or activities that might affect or interfere with the current geological feature are possible. And as you can see, our road, the outline of the road is closer to the coastal region, which means it's actually a wet underwet region. These are the standards that we used when doing this project. We used geometrical design of rural roads, that is TRH 17, Department of Transport Republic of South Africa, Geometric Design of Rural Roads, TRH4, Department of Transport, Republic of South Africa, and Geometric Design Manual, SANRAL, Republic of South Africa. Analysis and structural period. The structural design period the predicted period with a structure is designed to last without improvements. 30 years in the recommended structural design period SDP for Class B road category. Since the road is to be realigned, our SDP will therefore be reduced to 20 years. We can refer this to we use the TRH4. Analysis period. Analysis period is the lifespan of a structure to which it can be used. An engineer will choose the analysis period based on the information given about the road. If the road alignment is fixed, a period of 30 years should be selected. The analysis period in the road we have been tasked with designed, therefore, going to 20 years due to financial constraints. Design traffic. The cumulative equivalent traffic is equal to the total equivalent traffic loading. As we calculated it in our project, we got 3.4 million E80 per lane per day, which falls under under class ES10. Projection of the traffic loading over the SDP. The road will be opened after 2 years of determination of Excel data. The growth factor is found to be 1.12. We calculated it in our project, and the AADE is found to be 239.97 E80s per lane per day. Traffic growth is expected not to exceed 4% per annum. Traffic growth is expected to be 6.75 per annum. Traffic growth sometimes is not correctly estimated due to the ever increasing population. There are few things as a designer you need to consider when designing a pavement. Will all the environmental issues around have an impact on the generating additional heavy traffic? Material. So we can either use a granular basis or asphalt hot mix basis. But as per our project, we found the asphalt hot mixes basis to be the most convenient to use. So under granular basis, these materials are regarded as stress-dependent behavior, and under continuous loading or stresses, deformation of a pavement can occur through shear. In order to reduce or prevent deformation of pavement, traffic needs to be controlled. Other than compaction of granular basis to a required density for strengthening, low quantities of cement can be used to improve the strength. The occurrences of distress are usually shown by the pavement and are largely controlled by the type of sub-base. Normally, deformation can show itself as either as rutting or as surface roughness. Asphalt hot mix bases. In asphalt hot mix bases, they are normally subjected to fatigue, cracking, and there are two types of sub-bases: an untreated granular subbase or stabilized cemented subbase. Normally, rutting can either arise from untreated, stabilized, or asphalt layer. Asphalt bases are used because they are impermeable. And now going to the civil designer software that we chose to use. The civil designer software is a collection of a fully interactive design modules that work together to create a comprehensive data collection, sketching, surface modeling, and design system. I use this software because it is incorporated with the South African design standards, for example, the TRH1, and also it is easy to adopt. And this is how I used the program. I imported the survey points. Then after that, I created existing surface of the ground. I created an alignment. I then created the proposed profile. Then I modified the profile that is the cut and fill. I create finished ground surfaces. Then I print out the section views. This is my presentation of how I did my project. And I thank you.